August 15th, 1944. Tinian Island, Mariana Islands, Western Pacific. Lieutenant Edwin Stone drops to one knee on the newly poured runway surface, drives his fist into the pavement with full force. The impact jolts through his wrist, rattles his shoulder. The concrete doesn't crack, doesn't chip, doesn't even scratch. He stands brushing coral dust from his knuckles and stares across runway Able, stretching toward the Pacific horizon. 8,500 feet of arrow-straight pavement. Behind him, 3 more identical runways march in parallel across what was 6 weeks ago raw jungle and jagged coral bedrock. The entire northern end of Tinian Island has been transformed into the largest airport on Earth. Built without a single ton of Portland cement. This shouldn't exist. Japanese military engineers occupied Tinian for 30 years. Built one airfield using imported cement from Truk Lagoon. 14 barges, 3,360 tons. Construction time, 8 months for one runway 4,200 feet long. American planners ordered 4 runways. Each 8,500 feet long. Total 6.8 million square feet. Conventional concrete would require 1.7 million tons of material. Shipping time, 3 months minimum. But there it stands. The answer begins 6 weeks earlier with one man's past failure. August 2nd, 1944. Northern Plateau, Tinian Island. Commander Carlisle Brennan, 42, stepped off the landing craft. A bridge engineer from Pittsburgh before the war, he'd overseen 11 forward bases across the Pacific. But this project eclipsed everything. 4 parallel runways, each 8,500 feet long, 200 wide. Complete infrastructure for 20,000 personnel. Deadline October 1st, 60 days. That afternoon, Brennan assembled senior staff. Lieutenant Commander Thaddeus Merrick, 35, spread captured Japanese documents across the table. MIT Professor Hoover Dam engineer. He knew materials, knew what was possible. Japanese built one runway in 8 months, Merrick said. Imported everything. We need 4 in 60 days. No cement available anywhere in the Pacific. Lieutenant Edwin Stone, 29, stood near the entrance. Thin, sunburned. He'd worked on dam projects in Colorado before the war. Proposed an innovative design that failed catastrophically. $200,000 wasted. He was fired. Joined the Navy to escape that failure. Now another impossible project. Lieutenant Stone, Brennan said. Assessment. So coral bedrock is extremely dense. Blasting is possible, but pavement is the problem. Can't get cement in time. Merrick nodded. I recommend requesting timeline extension. Extension means 4 weeks of soldiers dying while we provide no air support, Brennan said. Stone spoke carefully. What if we explored alternatives to cement? Merrick's head snapped toward him. There is no alternative. If there were, I'd know. What if there's a local binding agent? Lieutenant, I taught at MIT, worked on Hoover Dam. This isn't the place for untested theories. Stone recognized that tone, the same dismissal before his dam failed. He kept quiet. That night, Stone's mind drifted to a geology lecture. Something about limestone and seawater. Natural cementation. He pushed it aside. Couldn't afford another failed innovation. August 3rd, 1944. Drilling teams attacked coral bedrock at dawn. Jackhammer drills punched holes 6 feet deep. Brutal work. Dense coral fractured expensive bits. Stone walked the site. Near the ocean, crushed coral stockpiles waited. Something caught his attention. Piles nearest the water looked different, surfaces crusted over, almost cemented. He knelt, scraped with his knife. The crust was hard, coherent. Something had bound it. Salt spray from the ocean. Morning dew carrying dissolved minerals. Stone collected a sample. That evening examined it under flashlight. The crust wasn't compressed, chemically altered. Calcium carbonate from coral, magnesium salts from seawater. A reaction. He remembered. Magnesium oxychloride cement. Discovered 1867. Formed when magnesium oxide reacted with magnesium chloride. Created rapid hardening cement without Portland materials. Could crushed coral mixed with seawater work similarly? The Japanese occupied Tinian 30 years. Their engineers were Tokyo-trained. Surely they'd have noticed, unless they never looked. Just followed procedures, imported proper materials. Stone needed someone practical. He found Sergeant Alistair Drummond. Sergeant Drummond, 41, master mason from Philadelphia. 20 years building foundations. He understood concrete intuitively. "Sergeant, look at this." Stone showed the sample. Drummond examined it. "Almost like cement bonded it. What if we replicate it? Mix crushed coral with seawater. Test if it hardens." "Lieutenant, I've mixed concrete 20 years. You need Portland cement. Water alone doesn't work." "One test, just one batch." Drummond sighed. "When it doesn't work, we never speak of this again." "Deal." August 7th, 1944, 11:30 p.m. Stone couldn't sleep. He walked into the tropical night. Waves crashed a quarter-mile distant. He approached the stockpiles. The pile closest to the ocean had hardened surface. He knelt, ran his hand over it. The top 6 inches had hardened into coherent mass. Another pile, 50 yards inland, remained loose. Stone sat on the hardened crust, worked through chemistry, calcium carbonate in coral, magnesium chloride in seawater. Mixed together, magnesium ions would replace calcium ions, form magnesium hydroxide, magnesium carbonate, compounds that crystallized, created interlocking matrix binding particles. Natural cementation, accelerated, hours instead of eons. Could it work at scale support? 70-ton bombers, chemistry seemed sound. But Stone had been certain in Colorado too. He needed to know. Stone woke Drummond. "Need you now. Bring mixing tools." Something in Stone's voice convinced him. Drummond grabbed tools and followed. At the beach, Stone showed him the cemented layer, explained chemistry. Drummond examined it. "I'll be damned." "Help me test it." "What ratios?" For 4 hours they mixed crushed coral with seawater, 6-1, 7-1, 8-1, 9-1, poured into wooden frames. By 4 a.m., 12 test samples cured under stars. "Now we wait," Stone said. August 8th, 1944, 6:00 p.m. 24 hours after pouring. The 8-1 mixture had transformed. Surface rock hard. Stone struck it with his hammer. Hammer bounced. Concrete showed no damage. Drummond pulled a sledgehammer. Swung with force. Impact rang out. Concrete cracked slightly but held integrity. "This is concrete. Genuine concrete. Strong enough for runway. Strong enough to investigate. Show Commander Brennan." August 9th, 1944, 9:00 a.m. Command post. Stone and Drummond placed the sample on the table. Stone explained. The hardened stockpile. Overnight tests. 8-1 ratio. Chemistry of calcium carbonate reacting with magnesium salts. Merrick examined it. Made with crushed coral and seawater impossible. Won't have required strength. So request permission to build test section. 200 by 200 feet. If it fails, 2 days lost. If it succeeds... "If it succeeds, we're gambling the bombing campaign on your hunch," Merrick interrupted. "Engineering isn't about hunches. It's proven methods. We need real cement." Brennan held up his hand. "Command a timeline for obtaining cement." Merrick consulted notes. 6 weeks minimum. Full quantity in 12 weeks. 4 weeks past deadline. "Yes, sir." Brennan walked to the entrance, looked at 2,400 men working, millions in equipment, all committed to a project that couldn't be completed. He turned back. "Lieutenant Stone, complete honesty. How confident are you?" Stone wanted certainty, but honesty first. 70% confident the chemistry works, 50% it achieves required strength, 30% it holds under sustained operations, but 100% confident that without trying we miss deadline by a month. Every week late means thousands of casualties. Brennan nodded, turned to Merrick. "Assessment. I think Stone is wrong, but right about timeline. We're not getting cement in time." Brennan made his decision. "Lieutenant Stone, 48 hours to build your test section. If it achieves 2500 psi or better, we proceed. If it fails, we accept the delay. Yes, sir. Don't thank me. If this fails, both of us explain to Congress why we bet the Pacific War on seawater and rocks. Merrick stood. Sir, I want my objection noted. Noted. And I want you supervising testing. Find the flaws before we pour 6.8 million square feet. Merrick picked up the sample. I'll test this until it breaks. When it does, we'll know why Stone's theory doesn't work. He left. Brennan waited, then turned to Stone. I'm giving you this chance for one reason. Not because I believe your chemistry, but because you're right about timeline. We're out of options, so I'm betting on desperation. Yes, sir. Sergeant Drummond is your responsibility. If this fails, he goes down with you. Stone assembled his crew, 20 Seabees, experienced construction workers. Corporal Dale Pritchard, 22 from Oklahoma, raised his hand. Sir, we're making concrete from ocean water. That's right, Corporal. Think it'll work? Stone met his eyes, saw the doubt. Honestly, I don't know for certain, but I know we must try. Alternative is waiting 3 months for cement. That means soldiers keep dying while we have empty runways. Pritchard nodded. Then let's make ocean concrete, sir. The crew laughed. Tension broken. Stone marked the section. 200 by 200 feet, 40,000 square feet, one piece of eventual 6.8 million. If this failed, there would be nothing. They worked through the night, mixed coral with seawater, 8-to-1, spread to 6-inch thickness, compacted with 12-ton roller, 6 overlapping passes, finished at dawn, August 9th, now waiting. August 10th, 1944, 4:30 a.m., 36 hours after pouring. Merrick arrived with testing equipment, cone penetrometers, compression apparatus, positioned instruments across the section, drove them in with hammer blows, recorded measurements. Stone and Drummond watched silently. Merrick completed 15 test points, consulted tables, calculated. His face revealed nothing. Brennan's voice behind them. Well? Merrick looked up. Something flickered. Surprise. Based on readings, I estimate 2,400 to 2,600 pounds per square inch. Silence. 2,500 was threshold. They were at the edge. This coral concrete has comparable strength to conventional concrete, Brennan asked. Preliminary measurements suggest acceptable range. However, I recommend laboratory verification. We don't have 72 hours, Stone spoke. Sir, request load test. Drive fully loaded dump truck across it. 32,000 pounds. If it cracks, we know it's inadequate. If it holds, we have verification. That's gambling, not science, Merrick said. This entire project is gambling. Brennan considered. Commander, if the section survives, does that demonstrate structural integrity? Merrick's jaw tightened. Marginally, yes. Then we test. Now. 20 minutes later, Chief Frank Kowalski pulled up in a 10-ton dump truck. Bed loaded with coral. Total weight 32,000 pounds. You want me to drive across that, sir? Slowly. Stop in the middle 30 seconds. Then complete crossing. If it breaks, stop immediately. Kowalski climbed in. Hoping your ocean concrete works, Lieutenant. Started engine. Shifted to first. Truck rolled forward. Front tires contacted coral concrete. Stone watched for cracks, for deflection, for failure. Truck advanced. 10 feet, 20, 30. Reached center. Kowalski stopped. Full weight settled. 30 seconds. No cracks, no deflection. Pavement held. Kowalski drove forward. Completed crossing. Stone sprinted to center. Knelt. Examined surface. No visible damage. No tire impressions. No deflection. He looked at Merrick. It held. Merrick walked across slowly. Examined tire tracks. Ran penetrometer again at maximum load point. Finally straightened. Pavement survived without apparent damage. Strength appears adequate. Brennan stepped onto the section. Walked to center. Knelt. Drove his fist into concrete. Same gesture Stone had made. Pavement didn't crack. Brennan stood, brushed dust from knuckles, looked at Stone. "Lieutenant, you just bought permission to build 4 runways. Don't make me regret this." "No, sir." Brennan addressed the crew. "Gentlemen, we are committed to the largest concrete project in the Pacific. Using material that didn't exist 72 hours ago. Commander Merrick establishes quality control. Sergeant Drummond trains mixing crews. Lieutenant Stone oversees chemistry. Full production in 48 hours. 56 days to complete 6.8 million square feet. Questions?" Pritchard raised his hand. "Sir, what do we call this?" Drummond spoke. "Coral concrete." "That's what it is." Brennan nodded. "Coral concrete. Dismissed." As crew dispersed, Merrick approached Stone. "Lieutenant, I'm not convinced this is adequate. I believe we're taking enormous risk. But Brennan decided, so I support it. However, I will test every batch. Inspect every pour. Check every measurement. If I find any deviation, I shut down immediately. Clear?" "Crystal clear, sir." 2,400 men are betting on your chemistry. Make sure it works." Drummond moved beside Stone. "You did it. We did it. You mixed that first batch. If it fails, then failure belongs to both of us. Then we'd better make sure it doesn't fail." Stone looked across the section, 200 by 200 feet. Proof impossible could become possible. Now replicate this 34,000 times in 56 days. With the Pacific War depending on it. August 12, 1944, 5:47 a.m. The first blast shattered pre-dawn calm. 96,000 pounds of TNT detonated simultaneously in 11,400 holes across a 400 by 600-foot section. Ground erupted. Coral bedrock fractured. 180,000 cubic yards lifted into the air. Shockwave rattled equipment 3 miles away. When dust settled, Seabees had excavated the first section of runway able to 15 feet depth. 48 Caterpillar D8 bulldozers moved in. Behind them, crawler tractors pulled electric scrapers. 24 cubic yards per load, shuttling between blast zones and crusher stations. 24 hours daily. Stone had designed 6 mobile mixing plants, each with water tower continuously filled by tank trucks running to the ocean. Crushed coral arriving in dump trucks. Calibrated gates controlling flow into rotating mixers. Ratio was critical. 8 parts coral to 1 part seawater. Too much water, too wet to compact. Too little reaction wouldn't proceed. Stone trained 6 operators, Seabees with civilian concrete experience. They'd adjust ratios continuously based on incoming moisture. Mixed material poured into dump trucks. 12 cubic yards per load. Drove onto runway beds, dumped in precise rows. Motor graders followed, spreading to uniform 8-inch thickness, then compaction. 12-ton rollers applying 400 psi surface pressure. 6 passes minimum, each overlapping previous by 6 inches. 3 days into production operation achieved rhythm, 300 tons per hour. 7,200 tons daily. 1 mile of runway every 72 hours. Stone walked sites 18 hours daily. Checking ratios, inspecting compaction, taking samples for Merrick's testing. Lost 15 pounds in 2 weeks. Never slept more than 4 hours. But runways were growing. August 19, 1944, 2:17 p.m. Chief Kowalski found Stone inspecting fresh pour. "Lieutenant, serious problem at Crusher Station 2. Stone ran. Crowd gathered around the primary jaw crusher, 90-ton machine, 200 horsepower motor, silent. Drummond stood beside it. "Main drive shaft has 6-inch lateral fracture." Stone examined damage. 10-inch diameter shaft showed visible crack. Underload complete failure inevitable. How? Corals harder than anticipated. 17 days maximum capacity. Shaft couldn't handle stress. Replace it. Nearest replacement is Pearl Harbor. 6 weeks minimum. Stone calculated. Station 2 provided 40% crushing capacity. Without it, 60% of required material. Missed deadline by 3 weeks. Options. Field weld repair. I've done shaft repairs in Pittsburgh mills, but this is cast steel under tremendous rotational stress. Weld must be perfect. Any flaw and shaft explodes under load. How many die if it explodes? 6 minimum, including whoever's welding. Stone studied the crew. These men had families, futures. But without Crusher, project failed. Bombing campaign delayed months, thousands dying. War's mathematics were brutal but clear. I'll design the welding jig, calculate stress points, determine parameters. If we attempt this, we do it with every engineering advantage. Even with perfect calculations, extremely dangerous. Less dangerous than mission failure. Stone spent 6 hours with manuals and slide rules, calculating thermal expansion for cast steel, determining optimal welding temperatures, designing jig to hold shaft in perfect alignment. By 8:00 p.m. had complete specifications. Found Drummond in mess tent. I have the plan. Weld at 2500 degrees. Preheat shaft to 400 to prevent thermal shock. 3-layer technique. First for penetration, second for strength, third for surface. Total time 4 hours, cooling 8 hours before testing. Drummond studied calculations. This might work. Will you do it? 23 years welding, done repairs on bridges, buildings, ships, never attempted anything this critical. If you can't, nobody can. Long pause. I'll need 2 assistants, men who understand they might die. I'll find them. And Brennan needs to approve. If Crusher explodes, that's his responsibility. August 19th, 1944, 10:00 p.m. Brennan reviewed Stone's presentation, studied specifications. We're attempting repair with 65% probability of catastrophic failure. Yes, sir, but if we don't, 100% probability of missing deadline. If it fails, we lose 6 men and the Crusher. Correct. Brennan turned to Merrick. Assessment. Calculations are sound. Stone knows metallurgy, but too many variables. Impurities, microfractures, environmental factors. In civilian context, I'd never authorize this. But this isn't civilian context. In military context, where alternative is mission failure, calculated risk might be acceptable. Brennan stood, stared at construction site. Equipment under floodlights. Men working night shift. Turned back. I'm authorizing repair, but I'll be present during welding. If men die, happens on my watch. Yes, sir. This better work. Because if not, I explain to 6 families why their husbands died welding a Crusher shaft. August 20th, 1944, 6:00 a.m. Drummond assembled welding team. Chief Webb and Petty Officer Hayes. Both experienced. Both volunteers. Damaged shaft positioned in Stone's jig. Preheating burners bringing metal to 400 degrees. Stone stood with Brennan 30 yards behind protective barrier. If shaft exploded, they'd survive shrapnel. Drummond positioned welding mask. Gave thumbs up. Stone returned it. Welding began. 4 hours watching 3 men work with molten metal exceeding 2500 degrees. Laying bead after bead along fracture. Building weld in 3 layers. Shaft glowed orange-red. Heat radiating in visible waves. Brennan stood beside Stone entire time. Silent. Watching. 10:15 a.m. Drummond shut down torch. Stepped back. Shaft lay cooling. 8 hours needed before testing. Now we wait, Stone said. Now we pray, Brennan replied. August 20th, 1944, 6:30 p.m. Shaft cooled to ambient. Drummond's team reinstalled it. Aligned bearings. Connected motor. Crowd gathered. 200 Seabees. Everyone knew stakes. Stone at controls. Hand on start switch. Merrick beside him. If this fails, entire Crusher disintegrates. Shrapnel flies 300 feet. Everyone in that radius dies. I know. Then why 200 men within shrapnel range? Stone looked at assembled Seabees. Determination on faces. Because they're Seabees. They face danger together. Merrick nodded. Let's discover if your calculations were accurate. Stone flipped switch. Motor hummed. Power flowed. Crusher's jaws began moving. Slowly, then faster. Repaired shaft rotated. Once, Twice, 10 times, 20, 50. Crusher reached operational speed, jaws opening and closing in rhythm. No explosion, no failure. Weld held, tremendous cheer, hats thrown, men embracing, shouting. Drummond walked over, extended hand. Your calculations saved this operation. Your welding saved it. I just did math. Brennan approached. Outstanding work. Now get this crusher processing. We're still behind schedule. As crowd dispersed, Brennan pulled Stone aside. You bought us 2 weeks with that repair, but demonstrated something more important. You can solve practical problems under extreme pressure. That's what we need. Thank you, sir. Don't thank me. We've got bigger challenges ahead. August 24th, 1944. 8:00 a.m. Runner found Stone. Commander needs you. Urgent. Stone jogged to command. Brennan and Merrick studying weather chart. Tropical storm forming 800 miles southeast, Brennan said. Hits Tinian in 36 hours, 60 to 70 mile winds. Heavy rain. Stone's stomach dropped. So runway Able has 1,200 feet poured yesterday. Only 18 hours into 24-hour curing cycle. Needs 6 more hours before handling moisture. I'm aware. Merrick pointed to chart. Standard procedure, halt paving. Cover with tarps. Tarps trap moisture underneath, Stone said. Trapped vapor interferes with curing, weakens concrete. Alternative is rain washing away partially cured pavement, $48,000 and 3 days' work. Stone thought fast. Test section cured perfectly with salt spray. Moisture accelerated reaction. What if we don't cover anything? Let storm pass. Trust chemistry. Merrick stared. Leave 1,200 feet exposed to tropical storm. Let natural curing continue. Rain won't wash away concrete already hardening. Salt spray might strengthen reaction. Pure speculation. Zero data on coral concrete in tropical weather. We had zero data on whether it'd work at all. We tested it. It succeeded. I'm proposing we trust the material. Brennan cut in. Confidence level. Stone paused. Honesty. 40% pavement survives undamaged. 60% confident tarping causes more damage. So, 2 risky alternatives. Yes, sir, but one lets us continue paving. Other forces halt. Brennan studied chart. How much additional pavement scheduled next 36 hours? Another 800 feet. If we stop now, save 1,200 but sacrifice 800 potential progress. And if we continue and storm destroys everything, lose 2,000 feet, 4 days, set us back a week. Brennan silent, then decided. Continue paving, no tarps. Trust Stone's chemistry. Find out now if this material handles tropical weather, because if it can't survive one storm, we need to know before completing all 4 runways. Merrick's jaw tightened. Sir, I must object. Objection noted, but we're already committed. We'll learn its limitations under real conditions. Lieutenant Stone, you're responsible for documentation. Photographs before storm, detailed measurements. Yes, sir. August 25th, 1944. 11:00 p.m. Storm hit. Stone stood beside runway Able with Merrick and Kowalski. Wind gusting 60 mph. Rain in horizontal sheets. Kowalski's crew erected temporary windbreaks. Corrugated metal panels, not protecting from rain that had trapped moisture. Reducing wind erosion on edges. Stone watched water stream across coral concrete. Watched pavement darken. Waited for erosion. For failure. Hours passed. Midnight. 1 a.m. 2 a.m. Storm peaked 3 a.m. Winds hitting 70. Rain torrential. Visibility 10 feet. 4 a.m. wind eased. 5 a.m. rain slackened. 6 a.m. dawn through breaking clouds. Stone walked onto runway. Boots splashed standing water. Approached section poured 24 hours earlier. Most vulnerable. Knelt. Pressed hand against wet surface. Felt texture. Hardness. Pavement survived intact. Merrick joined him. Ran examination. Pulled testing equipment. No erosion. No washout. Surface intact. Stone noticed something. Pavement felt harder than before storm. Merrick pulled cone penetrometer, drove into surface, measured resistance. Compressive strength significantly higher than pre-storm readings. Salt spray, ocean moisture, accelerated the reaction. Merrick took measurements at 15 points. All showed increased strength. He stood. Something changed in his expression. Skepticism gone. Lieutenant Stone, I owe you genuine apology. I've been skeptical from beginning. Doubted chemistry. Questioned methodology. Dismissed innovation because it didn't conform to established practice. But this material survived conditions that had damaged conventional concrete and got stronger. Sir, you were right to be skeptical. No, I was wrong. Not about being cautious, about dismissing innovation because it didn't match what I'd been taught. You saw possibility where I saw only risk. That's the difference between competent engineering and breakthrough engineering. Stone didn't know how to respond. No how. From this point forward, I'm not merely quality control. I'm active advocate. We'll document everything, test everything. When this war ends, we'll publish papers about coral concrete. Make sure the world knows what we discovered. When they returned to command, Brennan was waiting. Report. Pavement survived intact, sir, Merrick said. Strength actually increased. Coral concrete appears more weather-resistant than conventional concrete in tropical conditions. Brennan allowed slight smile. Then we proceed. Resume paving immediately. September 3rd, 1944. 2:30 a.m. Stone woke to aircraft engines. Wrong pitch. Higher. Faster. Grabbed helmet. Sprinted outside. 6 Japanese bombers from south. Mitsubishi G4Ms. Launched from Iwo Jima. Final desperate attempt to destroy airfield. Anti-aircraft batteries opened fire. Tracers arced. Bombers scattered. Released ordnance. Stone hit ground as explosions erupted. Counted impacts. 5, 6, 7. Then massive explosion from runway Baker. Stone ran toward sound. Drummond, Kowalski, Pritchard running beside him. Reached runway Baker. Stopped. Crater. 8 feet deep. 12 across. Punched through runway center. 4 bodies near crater edge. Seabees on guard duty. Stone recognized one. Petty Officer Morrison. Concrete finisher from Ohio. Worked 18-hour days, 4 weeks. Drummond knelt beside each body. Checked pulses. Found none. 4 dead, sir. Stone stared at crater. At destruction. At waste. These men had names. Families. Futures. Morrison was 23. Had a fiancée in Cleveland. Talked about opening a construction business after the war. Now he'd never see Cleveland again. Brennan arrived with Merrick. Assessed scene. Casualty report. 4 KIA, sir. Merrick climbed into crater. Examined edges. Pulled samples. Stone joined him. Studied crater walls. Coral concrete fractured radially from impact, but fractures extended only 3 feet before stopping. Beyond that, pavement remained intact. Blast was contained, Stone observed. Crystalline structure prevented damage from propagating. Merrick nodded. Conventional concrete would have shattered wider. Coral concrete's matrix absorbed shock better than predicted. How long to repair? Crater 8 feet deep, 12 across. Excavate to clean edges. Pour new concrete. Cure. Minimum 48 hours. First B-29 arrives in 9 days. Can't afford 48 hours. Continuous shifts. 36 hours if we push everything. Stone studied crater. Idea forming. What if we modify formula rapid cure mixture? Slightly increase seawater ratio to accelerate magnesium reaction. Add compaction to compensate. Force curing faster. That formula hasn't been tested. Neither was original until we tested it. This is optimization. If accelerated curing creates weakness, that section becomes permanent failure. Then we test first. Pour rapid cure patch, monitor 24 hours. If adequate strength, proceed. If not, remove and use standard formula. Brennan cut in. Do it. Whatever gets runway operational fastest. Those 4 men died building this. We owe them a functional airfield. Stone felt weight of those words. Morrison died building this runway. The least they could do was finish it. Stone worked with operators developing rapid cure formula. 9 parts coral to 1 part seawater instead of 8 to 1. Extra water would accelerate reaction. but too much prevented compaction. Balance had to be perfect. Drummond supervised excavation. Crew cut clean walls, removed damaged concrete, prepared surface. By noon, ready to pour. Stone verified mixing ratio. Watched first truck. Followed to runway Baker. Modified mixture poured into crater. Graders spread level. Rollers compacted aggressively. 6 passes. 8. 10. More than standard to compensate. Pour completed 200 p.m. Stone stayed beside Patch. Merrick joined. Neither left. Every 2 hours, Merrick tested surface hardness. Recorded measurements. By midnight, 15 hours after pour, Patch achieved significant strength. By 8:30 a.m. next morning, 24 hours, Merrick ran full tests. Compressive strength, 3,400 pounds per square inch. Stronger than surrounding pavement. Stronger than test section. Stronger than any coral concrete produced. Rapid cure formula worked perfectly. Merrick looked at Stone with respect. This changes fundamental understanding. We can optimize entire formula. After runways operational. Right now finish what we started. Agreed. They walked to command. Brennan reviewing schedules. Runway Baker fully repaired, sir, Merrick reported. Patch cured to full strength. Runway operational. Brennan set down schedule. 36 hours from bomb damage to operational. Japanese took 8 months to build their runway, and you repaired combat damage in a day and a half. The material made it possible, sir, Stone said. But he was thinking about Morrison, about the rapid cure formula they'd developed to repair the crater that killed him. Morrison's death had accelerated their innovation, had pushed them to find better solutions. That didn't make his death worthwhile, but maybe it gave it meaning. By early September, all 4 runways paved complete length, 34,000 linear feet, 6.8 million square feet, largest continuous concrete pour in military history. Now the ultimate question, would it support a fully loaded B-29 September 12, 1944? 4:00 a.m. Stone hadn't slept. The first B-29 was inbound. Joltin Josie. Serial 4293825. Pilot Major Harlan Beckwith flying from Guam. Beckwith didn't know the runway was crushed coral and seawater. Briefing simply said, new concrete runway operational. 2,400 Seabees lined runway able. Standing at attention, watching southern sky. Stone stood with Brennan, Merrick and Drummond at threshold. At 4:30 a.m. they heard engines. 4 Wright R3350 radials, 8,800 horsepower combined. B-29 appeared against pre-dawn sky. Landing lights blazing, gear down, flaps extended. Stone's heart hammered. This was it. If runway failed, 11 men died. Project failed. Bombing campaign delayed months. Joltin Josie descended on final. Lined up with centerline, 100 feet, 50, 20. Main gear touchdown. 140,000 pounds impacting coral concrete at 125 mph. 70,000 pounds force on each gear. Distributed across 4 wheels. Instantaneous ground pressure exceeding design threshold. Stone watched touchdown point. Watching for cracks, for collapse, for catastrophic failure. B-29 rolled. Tires smoking slightly. Massive weight pressing down. Pavement held. Beckwith applied brakes. Superfortress decelerated. Rolled 3,200 feet. Turned onto taxiway. Silence for 5 seconds. Then 2,400 men erupted, cheering, shouting, helmets thrown, men embracing, jumping, crying with relief. Stone's knees weakened. He sat hard on runway edge, body shaking. Drummond sat beside him. "We did it." Stone couldn't form words, only nodded. Merrick stood over them, extended hand. Pulled Stone up. "Lieutenant, you just proved innovation beats convention. That material is spectacular." Beckwith taxied back, shut down engines, climbed out, looking confused at celebration. "Did I miss something?" Brennan walked over, shook his hand. "Major, you just became first pilot to land B-29 on runway, constructed from local materials. No imported cement. just crushed coral and seawater. Beckwith looked at pavement, knelt, touched it. This runway is coral. Coral concrete, invented here, tested here, proven operational 4 minutes ago. Beckwith stood. Gentlemen, I've landed B-29s from Kansas to Hawaii. This is the smoothest runway surface in the Pacific. Over 48 hours, 23 more B-29s landed without incident. By September 20th, all 4 runways fully operational. By October the 1st, exactly on deadline, 142 B-29s permanently based. Largest concentration of strategic bombers in the world, built in 60 days. Using pavement that hadn't existed before August 1944. November 24, 1944, 6:00 a.m. Stone stood in control tower, below 111 B-29s prepared for launch. First major raid against Tokyo since Doolittle's 1942 raid. Each bomber carried 20,000 pounds ordnance. Each weighed 140,000 pounds at takeoff. First B-29 began takeoff roll. Stone watched through binoculars, observing main gear compressing pavement, watching for structural failure. Bomber accelerated, 60 mph, 80, 100, 120, rotation, liftoff at 6,500 feet. Second bomber launched, 3rd, 4th, 10th, 50th. For 2 hours, Stone watched B-29s thunder down coral concrete runway, watched them lift off, form massive formations, turn north toward Tokyo. Brennan stood beside him throughout. Every bomber launching carries your innovation, Lieutenant. Coral concrete made this possible. Made it possible faster, sir. Speed is a weapon. You gave us speed. Final bomber launched. Formation departed north. 111 aircraft carrying concentrated firepower toward Japan. Stone thought about Morrison and the 3 others, who'd never witnessed this, never know their sacrifice enabled something this significant. Sir, request permission to visit cemetery. Brennan nodded. Granted. Stone walked to the small cemetery. 4 graves, 4 white crosses. He stood before Morrison's grave, 23 years old, never got to open that construction business. But Stone couldn't speak, the words stuck in his throat. He'd return, when he had the right words. March 4th, 1945. 7:23 p.m. Crash alarm sounded. Stone ran to tower. Controllers shouting into radios. Rover Boys Express, cleared emergency landing runway able. Fire crews standing by. Stone grabbed binoculars, found damaged B-29, left main landing gear gone. Shot away over Tokyo. Captain Lloyd Garrison nursing crippled bomber back on 3 engines. Landing on right gear and left wing, controller said. 40% survival. Stone sprinted to runway able. If pavement failed, 9 men died. Rover Boys Express lined up on final. Descended, right gear down, left wing low. Plan touchdown, right gear let, left wing contact runway to distribute forces. Touchdown, right gear hit coral concrete. 70,000 pounds impact. Pavement held. Bomber skidded. Left wing made violent contact. Metal screaming against coral concrete. Sparks showering. 2,400 feet skidding. B-29 rotated 90 degrees. Slid sideways. Stopped. 4,200 feet from threshold. Garrison and 8 crew scrambled out. Running from aircraft. No fire started. Stone ran to wing contact point. Knelt. Examined surface. Deep gouges where aluminum scraped coral concrete. But no structural failure. No propagating cracks. Pavement dissipated forces without breaking. Garrison approached. You're the lieutenant who invented this concrete. I'm Lieutenant Stone. Your runway saved 9 lives. That wing contact would have shattered conventional concrete. We'd have cartwheeled. We'd be dead. Stone stood. Material performed as designed, Captain. Grateful you're safe. Performed better than designed. I've made 3 emergency landings. First time pavement survived. By August 1945, North Field supported over 13,000 B-29 sorties. 4 runways handled over 26,000 takeoffs and landings. Average 18 operations daily for 10 months. Not one mission cancelled due to runway failure. August 6, 1945. 2:45 a.m. Stone watched from tower as Enola Gay taxied to runway Able. B-29 appeared identical to others. But cargo was unique. One bomb. Little boy. 10,000 pounds uranium configured for world's first combat atomic detonation. Colonel Paul Tibbets taxied onto runway Able. Same runway Stone tested first. Same runway where Joltin Josie made proving landing. Stone knew the mission. One airplane, one bomb, one city. Hiroshima. Enola Gay began takeoff roll, accelerated down coral concrete, lifted off with 3,000 feet spare, climbed into darkness, turned northwest, disappeared into history. Stone found Drummond near maintenance hangar. "Sergeant, you ever think about what we built?" "Every day, Lieutenant. We built a road, crushed rocks and seawater, but from this road, aircraft launching to destroy cities. That's war. We build tools. Others decide how they're used." "Does that absolve us?" Drummond quiet. "No, but doesn't make us guilty either. We built these runways to end war. If one mission convinces Japan to surrender, we probably saved millions. American, Japanese, millions. And if it doesn't work, then we keep flying until something does. But at least we gave our side every capability." 9 hours later, reports confirmed Hiroshima destroyed. 70 to 80,000 immediate casualties. August 9th, Boxcar launched from North Field, carrying Fat Man, target Nagasaki. August 15th, Emperor Hirohito announced unconditional surrender, exactly 1 year after Stone drove his fist into test section and discovered it was harder than it should be. August 15th, 1945. Evening. Stone, Brennan, Merrick and Drummond sat on runway Able. War over. Runways served their purpose. 91,000 tons ordnance, Merrick said. 13,274 sorties, all from these runways. Including 2 atomic missions, Brennan added. Stone looked at pavement, ran hand across surface. "We built this to save lives by ending war faster. Did we succeed?" "Strategic estimates say yes," Brennan replied. "Invading Japan would cost 1 million American casualties, several million Japanese. Bombing campaign killed substantially fewer." "That's the justification. Does it feel justified?" No one answered. Drummond spoke. "Lieutenant, we're not philosophers. We're builders. Mission: build 4 runways in 60 days. We built them in 56. Everything after those weren't our decisions. But we enabled them. Absolutely. Like men who built roads enabled Patton. Built ships enabled MacArthur. We build infrastructure. Others use it. That's how warfare works." Stone understood. But understanding didn't ease the weight. Later that evening, Stone returned to cemetery alone, stood before the 4 graves, Morrison, the 3 others. He knelt, placed 4 small fragments on the graves, coral concrete pieces from the runway they'd died building. "We finished it," he said quietly. "All 4 runways. War's over. You helped end it." His voice caught. "Morrison, you were 23. Had that fiancé in Cleveland. Talked about construction business. You should have got to build that. Should have gone home." He paused, gathered himself. "The rapid cure formula we developed to fix that crater. The one that killed you. That formula's better than our original. Stronger. We're going to use it for repairs across the Pacific. Your death pushed us to innovate faster, to find better solutions. That doesn't make it worthwhile. Doesn't justify it. But maybe it gives it meaning." Stone's chest tightened. "I failed before. In Colorado. Damn project collapsed. I thought I'd never build anything that mattered. You 4 gave me chance to prove failure isn't final. Thank you." He stood, saluted the graves, walked back. The runways would outlast him, would outlast everyone who built them. Physical proof that second chances exist. That redemption is possible. That failure can become foundation. For the first time since Colorado, Stone felt the weight lift. He'd been redeemed. 1946. War ended. Occupation beginning. Sergeant Alistair Drummond returned to Philadelphia, resumed building foundations for commercial structures, worked until retirement at 65, died peacefully in 1989 at 86. For 44 years he kept coral concrete sample on his desk. Reminder of the impossible thing we built, he told grandchildren. Chief Frank Kowalski went home to San Diego, worked shipyards as welding supervisor, trained hundreds of welders over 2 decades, died 1985. His family donated coral concrete sample to Seabee Museum. Corporal Dale Pritchard returned to Oklahoma, became civil engineer, designed bridges and municipal buildings, built infrastructure across Southwest for 30 years, died 2001 at 79. In every interview he credited Lieutenant Stone. He taught me impossible just means not yet attempted. All three stayed in contact with Stone until their deaths. Reunions every 5 years. Always brought coral concrete samples. Always told the story. Story of 60 days that changed warfare. Story of crushed rocks and seawater becoming runways. Story of men who refused to accept impossible. 1990. 45 years later. U.S. Army Corps of Engineers survey team arrived at Tinian to assess abandoned North Field. Structures unused since 1946. Overtaken by jungle. Forgotten, except by historians. Team included Dr. Robert Chen, materials engineer from Berkeley. He'd read Merrick's papers about coral concrete decades earlier. Fascinated by properties. Lobbied for funding to study long-term durability. Chen's team cut core samples from all 4 runways. Extracted concrete from sections poured August 1944, transported to laboratories in Guam. Test results revealed something extraordinary. Compressive strength 6,200 pounds per square inch. Coral concrete continued strengthening 46 years. Magnesium-calcium reactions proceeding slowly but steadily. Material had become twice as strong as conventional concrete. Stronger than any tropical pavement ever tested. Chen published findings in Journal of Materials Engineering, created renewed interest in coral concrete for modern construction, but Chen's paper included something else. Historical note, he'd tracked down Lieutenant Edwin Stone, found him in Colorado, 95 years old, still sharp. Chen visited personally, showed test results, strength measurements, chemical analysis. Stone read paper slowly, studied data, finally looked up. 46 years and still getting stronger. Yes, sir. Magnesium reactions continue as long as moisture present. In tropical climates, process may continue indefinitely. We had no idea it'd last this long. Just needed it to survive long enough to win war. You built something permanent, Lieutenant. Those runways will be there centuries. Stone quiet, thinking back decades, remembering Drummond, Morrison, night mixing first test batch by flashlight. We didn't build it to last centuries, Stone said finally. We built it to last 60 days. Everything after was bonus. 2023. 78 years after construction. Drone footage of Tinian reveals runways still visible through jungle. Outline of runway able traced for entire 8,500-foot length. Manhattan Grid Broadway and 8th Avenue remains discernible. Coral concrete, almost 80 years old, shows minimal deterioration. Sections cleared of vegetation remain structurally sound. Lieutenant Edwin Stone died peacefully 2023 at 108. In final interview 6 months before death, he was asked about coral concrete, about innovation, about what made Northfield successful. His answer, "People ask what I invented. I didn't invent anything. Nature created coral concrete millions of years ago. I just paid attention when others saw only obstacles." Japanese engineers were brilliant, better trained, better educated, but they waited for perfect materials, perfect conditions. We couldn't wait. We worked with what we had. Turns out what we had was exactly what we needed. We just had to see it differently. Interviewer asked about Colorado Dam failure. Stone's voice softened. After the dam, I was finished. Fired. Reputation destroyed. Everyone said I was too reckless, too innovative, too willing to ignore established practice. I joined Navy to escape. Thought I'd just follow orders. Build simple things. Never risk innovation again. Then Tinian happened. Brennan gave me problem with no conventional solution. Had to choose Try innovation again and risk another failure, or accept defeat and watch thousands die waiting for cement. Choice was obvious, but terrifying. When that first B-29 landed safely, when those wheels touched coral concrete and pavement held, that was the moment I knew. Failure in Colorado didn't define me. What I did after failure, that defined me. Tinian gave me redemption, not just as engineer, as human being willing to try again after catastrophic failure. That's the real lesson, not the chemistry. Not the construction speed. The lesson is, failure is an event, not an identity. What you do next, that's who you are. Interviewer asked about 4 men who died. Stone's eyes watered. Morrison, the 3 others. They haunt me still. Not with guilt they volunteered, same as everyone, but with responsibility. They died building something that mattered. My job is make sure it mattered. Make sure people remember what we built, why we built it, what it cost. 4 men dead, hundreds of thousands lives saved. War ended months or years earlier. Mathematics are clear, but mathematics don't ease the haunting. Nothing eases that. Stone paused, gathered himself. But I can honor them, by making sure their story gets told, by making sure people understand what they built, by making sure their sacrifice meant something. That's all I can do. That's all any of us can do. Runways at Northfield Tinian remain today as abandoned 1946. Overgrown, unused, but intact. Coral concrete achieved compressive strength exceeding 6,500 psi. Strongest surviving pavement in Pacific Theater. 13,274 B-29 sorties. 91,000 tons ordnance. 2 atomic weapons. War ended. All made possible by runways built in 56 days from crushed island coral and Pacific seawater. Japanese said 8 months minimum using proper materials. American Seabees accomplished it in 8 weeks using materials beneath their feet. That difference defined more than construction methodology. It defined American approach to impossible problems. Examine what you need. Examine what you have. Find the connection. The obstacle isn't blocking the path. Sometimes the obstacle is the path. Stone understood this August 1944 when he noticed hardened coral. Understood it September when first B-29 landed. Understood it August 1945 when war ended. And understood it 2023, dying at 108, when he told interviewer, "We didn't make coral into concrete. We just recognized it already was concrete. We just had to see it." Runways remain, 80 years old, still strong, built in 56 days by 2,400 men who refused to accept impossible. Proof that American ingenuity applied with courage and speed can overcome any obstacle, even obstacles made of coral harder than steel.